lesson 36, reviewing angles that are bigger than 360 degrees, so we go around the circle more than once, and both in the river problem. So as we talked about way back early on this semester, coterminal angles are just angles that end up at the same place. They differ by integer multiples of 360. So when we have something bigger than 360, we need to figure out what's the coterminal one that is the first time around the inner circle that ends up at the same place, so that it's one we know how to work with. So if we have 765, it's positive, so we're going that direction. And what I do is I just say, okay, I go around once, that's 360. Twice, that's 720. How much more do I still need to go to get to 765? And if I'm not sure, I can actually subtract the 720, which would differ by a multiple of 360, and get that, oh, I'm just talking about 45 degrees. If we have memorized that the cosine of 45 degrees is positive root 2 over 2, we write it down. If we haven't, we say, well, here's what my triangle looks like, 1, 1, root 2. Adjacent is 1, hypotenuse is root 2, and if I rationalize the denominator, I get root 2 over a regular 2. Then I need to subtract the sine of 330. That's less than one time around the unit circle, so I know that has me ending up all the way around here, so I'm in the fourth quadrant. So real fast, is sine positive or negative? Everybody. Negative, because sine's the y coordinate. Y's are positive up there, negative down here. So this is going to be minus a negative something. And if I've memorized, oh, that's the highest one in the unit circle, so out of the possibilities, a half, root 2 over 2, and root 3 over 2, that one has to be negative a half. And if I haven't memorized it yet, I've already figured out that it's negative, so I can think of any 30, 60, 90 triangle. And if I take opposite 1 over hypotenuse, I have the 1/2. I put that after the negative sign because it's the fourth quadrant, and then I have this other minus sign. So I end up with plus a half. So if I put all of that together, root 2 plus 1, all over 2. Comes up, comes down, in between. Pretty easy, like I said, that one was a review one. Let's do a couple of these that are a little bit harder and messier before we go on to the boat problems. So, first one, 540 degrees is more than 360. So I'm going to go around 360 degrees, and then I need to keep going. 720 would be the next, so it's between 1 and 2 times around. And if I'm not sure, I can actually subtract and say that I am looking at I'm looking at 180 degrees is where I would have to end up. So that's the tangent of 180 degrees. Who remembers what the tangent is when I am on the x-axis? If it's the left over there. Okay? It is indeed 0. And remember, that point would be -1, 0 if the radius is 1, so we're on a unit circle. Tangent is also sine over cosine, so it is also the y over the x. So 0 over -1, it's okay to have 0 in the numerator, so that's just 0. Then we have minus the sine of 450. So for 450, we're going to go in the positive direction. 360, keep going. Another 90 would have us at 450, so that is minus the sine of 90 degrees. If these coordinates are cosine of the angle, sine of the angle, if the radius is 1, what would be the y-coordinate there at the top of the unit circle? What we have there? We would have positive 1, so we're going to have minus 1 right there. Then we need to have plus the cosine of negative 390. This time we need to go in the negative direction. So we're going to go around one complete turn, that's 360. Keep going another 30 degrees. So we remember the cosine when we are at the highest one that's in the fourth quadrant. First, the cosine is the x of the y. Everybody. What? Louder. What's cosine x of y? I got it right here. The cosine of the x is the x positive or negative in that fourth quadrant. So x is your positive over here. X is your negative over here. So this is going to be a positive something, so I don't really need to write it down unless it helps me get it correct there. If we remember that at that place on the unit circle, if this one is 1, this one is root 3 over 2, root 2 over 2, and 1/2 as far as my x values are concerned. So that's root 3 over 2. If I don't remember that, I draw a 30, 60, 90 triangle. So this is 30. This would be 1, 2, root 3. I do adjacent overhead values, and I have a root 3 over 2. So I have negative 1 plus root 3 over 2. And I could leave it like that. Add the 0 to it, and that's all I have. Or I could write it with a common denominator. I didn't get either. How do you feel about that? You good with it? And that comes down. Okay, one more. Negative 405 degrees and negative 780 degrees. So be sure we're going in the negative direction. Going to go negative 365, that's not far enough. And then I have to keep going. How many more degrees do I need to go in the negative direction? I go all the way around the negative direction once. How many more do I need to go? 45. That's pencil in. So we'll end up at negative 45 degrees. Or, if I want to think about that in terms of positive degrees, I could say that's the sine of 315 degrees. In your work, I'm okay if you leave that at negative 45. That lets you know you're right here. You can tell me what the sine is right there. And there's the y. So y is your positive up above, negative below. Don't look, I'm going to do all the work for you. Anybody who hasn't answered? What is the sine when I am there? Is that fully off the way so I can go there too? I'm trying to see who it is. It's S on as well. I'm an X. I'm going off of I's. Okay, very good. We'll get to negative because it's below the x-axis. And that one would be root 2 over 2. And again, we can draw the reference triangle if we need to. Okay, then we are going to do negative 780, so we're still going this direction, but it's negative 780 degrees, all the way around to 360, all the way around again to 720. How many more do I need to keep going? I need to keep going another 60 degrees, so I am also at negative 60 degrees. It's fine to leave it like that in your work. If you prefer, you could say 90, 180, 270, you could say 300 degrees. Okay, will cosine be positive or negative in that quadrant? It's the x, and we're on the right of the axis, so it is a positive something. Who can tell me what the cosine is of the 3 on the unit circle? This is the smallest of those 3 x's. Can anybody tell me what that would be? If not, draw 30, 60, 90 triangle real fast to figure it out. What are the choices? The choices are a half, root 2 over 2, and root 3 over 2. Okay? It is indeed positive a half. By the way, it is wrong if you write cosine of that. Cosine is of an angle. This is the answer. This is the ratio. You could take the arc cosine of the ratio to get an angle, but you can't put trig in front of what that ratio is. Trig only goes in front of an angle. So now we have minus root 2 over 2 plus a half, or 1 minus root 2 all over 2 for that final answer. Everybody feel like you can do those okay? You just have to figure out where you are, and then if we're starting to memorize the unit circle values, we can write those in. The ones we're not sure of, we draw the reference triangle. Okay, switching gears, boat and the water problems. So, you go faster when you're going upstream or downstream. So downstream's faster. So downstream needs the bigger rate. For these, we are going to do rate times time equals distance. The tricky piece is there are 2 things that impact the rate. What 2 things affect if you're going upstream or downstream? What 2 things affect how fast you are going? Brendan? The current is one thing that affects it, right? How fast the water's going, or if you're in the air, how fast the wind is blowing. What else affects these kinds of motion problems? Sophia. What? How fast the engine's going, or how fast you're rolling, or how fast the airplane's engines make it fly. So, we do this as the standard form that we write these in. We're going to use B's and W's, B for the speed of the boat, and W for the speed of the current, but it could be airplane and wind or whatever in there. So we have B and we have W that need to impact the time right here. So if I am going downstream, I need a faster rate, which means I add them. If I am going upstream, it needs to be a slower rate. It is still going to be rate times time is distance. The rate is still going to be a combination of the boat speed and the water speed. And then times time equals distance, but now this is for upstream. So I need to subtract to get a slower rate. Now, it doesn't matter on upstream if I do B plus W or W plus B. It's the same thing. Does it matter going downstream? Is it B minus W like I wrote it, or is it W minus B? What do you think on that? In order to get anywhere, because these problems talk about you actually make it going upstream. Which one has to be faster if you're going to get anywhere going upstream, Caleb? The boat has to be faster or you're not actually going to make it upstream. You're going to get swept downstream. So, go ahead and put this in your formula page, and then we'll go back and actually solve this problem using these formulas. So then going back and using these in our problem, we know that the boat goes at 6 times the speed of the water, so boat equals 6W. We know that our downstream distance has to be 350, That's going to be our B plus W times our time downstream. And we know that the downstream time isn't 3 hours. It is 3 hours more than something. It is 3 hours more than the upstream time. And I know that the upstream distance was 150. And that's going to be E minus W times the upstream time. So now if I put that 6W in for both of the B's, I have 7W times 2U plus 7W times 3, so plus 21W equals 350. And if I also put the 6W in for this B, 6W minus 5 minus W is 5W, 2U is 150. Anybody have an idea of how I can simplify that second equation a little bit? Abby? So that's a little bit nicer. W times 2U is simply 30. Does that help me with anything? Yes. Good. So I can take this W2U and plug that in for this W2U. So that means that I have 7 times the 30 plus 21W equals 350. Go ahead and finish solving that from there. Yes, for those who were thinking about it, I could have taken this one right here and divided everything by 7 before I went on and did the substitution. That's also okay, because 721 and 350 are all multiples of 7. So I could have done the same kind of thing I did with that I did by dividing by 5 here. Who has W for us? And it's not the nicest number in the world. It's a fraction. Right, I only have one hand coming up. It would be 23rds. Now, why don't I want to go ahead and say 6.666, 6.667 right now? Yep. Because that, I'm not done. I need to, you can't really see, but this one specifically said find the speed of the boat. I don't want to round and then reuse it. So the boat needs to be 6 times the speed of the water. So I am going to take that the boat is 6 times the speed of the water. And then the 6 over the 3 cancels nicely. And I get 40 miles per hour for the speed of the boat. Question.